Alright, using the elimination method to solve a system of equations, which is the same as finding the point of intersection on a graph, just doing it algebraically. So to use elimination, we actually want to combine the two equations into one equation, but the key is we want one of the variables to be eliminated, either x or y. As I look at this system here, these two equations, if I add them together right now, nothing's eliminated. So what I want to do is make sure we have opposites. So I think it's easiest to make the x's just opposites. So if I change everything on the bottom, multiply everything on the bottom by -1. Remember, as long as whatever you do to one side of the equation, we can do to the other. So I just multiplied everything by -1. Now when you add the two equations, x and -x, well, makes 0. They eliminate each other. So then just add the rest of it. 2y and -y is y. 16 and -2 is 14. And we've already, there's nothing else to do from here for y. We do have to go back and find x. So I'm going to go back up. I think I will use the top equation. You can use either one, it doesn't matter, but I'm going to use the top equation and just rewrite that. And that will be x plus 2y, but now we know what y is. And we just solve from here, so let's finish that out. Just a little mistake there. There we go. Plus. So x must be -12. So we like to write that as an ordered pair since this would be a point of intersection. So my answer would be -12, 14 is where the two lines would cross. Of course, we want to check that out always. So the top equation should work out. So I'm going to plug both of my variables in to make sure it does. Alright. And there we go. Everything's right. So -12 plus 28. So it does check out in the first one. Also have to check the second one. The original second one was x plus y equals 2. So x plus y equals 2. And that is a nice easy one to check. From here on out, I won't check them to save time, but you should always check to make sure your answer is correct. And I think I'll square my solution. Okay, let's look at a couple more here. So we still want to use elimination, even though we do have substitution as a method, but we're working on elimination. One thing you'll notice here is I got my x on one side, my y on the other here, but they're on the left side. So you always want to make sure you line up everything properly. So before I move on in this problem, I want to just change this so that my x's and y's are all lined up. So I still have 2x, but I'm going to slide the y over, make that a -y. And from here, same type of problem. So we didn't really change it too much, just showing you that you want to line up everything. My x's are lined up, my y's are lined up, equal signs, and the constants on the other side all lined up and ready to go. So this is almost ready. I can cancel the x's fairly easily here. Once again, kind of the same thing we did before, just multiply everything by -1. If we combine the equations, we get 6y equals -18. Here we do have to finish off by solving for y. Divide everything by 6. And I will go back up, and of course I will find x. I think I'll do that in this first equation, or the second equation, underlined in blue. So 2x will equal -3 plus 19. Solving for x, work my way down here. Looks like x equals 8. And of course you'd want to check that out in both equations. But I've already shown you how to do that, so we are going to move on to the last one. So in this last one, you will notice it's what we need to cancel is not obvious right away. There's no easy, quick one to do here. In fact, in this one, I have to change both equations. It's a lot like finding the common denominator. I think I'll cancel the y's this time because we're already plus and minus, so that'll help us a little bit. So we just want to make sure the y's become opposites. So like I said, finding a common denominator, we're not finding a common denominator, but it's like that. So I'm going to change these so that I have plus 12y and minus 12y. That way they will cancel. Well, in order to do that, I need to multiply this everything in the top equation by 4. So that gives me 8x plus the 12y, because 4 times 3, and then 4 times 10 is 40. Do not forget to do the other side as well. There are some instances where people will leave it as 10, and that throws everything off. The bottom equation will need to be multiplied as well. How do I get negative 12? Well, I need to multiply everything by 3. All right. So I'll do that. So it turns into 9x. I already have my negative 12y, negative 6 this time. Now, if you notice, I don't need the top two equations anymore. I'll just use the ones I changed them into. They're equivalent from the top ones. So now when I combine them, the y's are gone. I'm left with 17x equals 44. And we will divide those by 17. Oops. No wonder that wasn't working out well. Let's go back. 34 is what it should be. That's a little easier to divide. Not that you always have to have an even number, but just notice something there. So x does equal 2. Can go back up to really any equation. I think I'll go back up to the original top one. So 2 times x, which we now know is 2, plus 3y equals 10. 4, go through and solve here. And if you notice, all these did come out to nice numbers. That doesn't always happen. And in fact, x and y turned out to be both 2. So we'd go to the point 2, 2. That's where these two lines would intersect. All right. I know you'll recall there are options. You know, if the variables disappear and you're left with like 3 equals 3, then it'd be all many solutions. If your variables both disappear and you're left with like 3 equals 10, then there is no solution because the lines would have been parallel to begin with. So that's it. There's your elimination method. Hopefully that helped.